Greetings, everyone. And in today's lesson, we'll look at chemistry. The topic is kinetic theory. Now, what is the kinetic theory of matter? So, this is kinetic theory, by the way, of matter. So, the kinetic theory of matter states that matter is made up of tiny particles that are in continuous random motion. This was experimented by the scientist called Robert Brown. That's why it's now even called the Brownian motion, because of the experiment that this person undertook. So matter is made up of tiny particles that are in continuous random motion. Then what is matter? So matter is anything that occupies space and has mass. Anything that occupies space and has mass is called matter. And you have forms of matter. Forms of states of matter are forms in which matter exists. Forms in which matter exists. That's what we call states of matter, or phases in which matter exists. Okay. So we have three. We have what we call solid, liquid, and gas. These are phases of matter or states of matter. Now, examples of solids we can have ice, stones. Those are to mention but a few. There are a lot examples of solids. Liquid here you can have cooking oil, water. They're just liquids. Gases, we have carbon monoxide, carbon dioxide, carbon disulfide, sulfur dioxide, and other gases. Examples of gases here. Now, the properties of these three states of matter. So now, when it comes to properties, you need to talk of number one, in terms of volume, in terms of space occupied, in terms of compressibility, in terms of movement of particles, and arrangements of particles. Let's start with solid. How is the volume of the solid substance? Let me use this as an example. The volume of this eraser or duster is fixed. So it has fixed volume. In terms of shape, fixed shape until an external force is applied. The volume is fixed. The space occupied is also fixed. In terms of compressibility, you can't compress this easily. It's highly incompressible. You can't compress this one. Okay? Then in terms of particles arrangement, how particles are arranged in solid particles, let me just show you. Particles are arranged in a closely packed and arranged in a regular pattern. In a regular pattern or pattern. Okay? So this is solid. So there is also order in the arrangement. It's irregular. So they are together. The fact that they are together, the fact that they're together doesn't make them as solid, but also the arrangement should be regular. Because you can have something like this. You can't say this one is solid. because the pattern is not regular. The arrangement is not regular because these particles can easily slide over each other. So this one, it must be liquid, as they may look closer, but they are not arranged in a regular pattern. So you have to be very careful in an exam, because you may mistaken liquid as solid for solid. Okay, that is arrangements of particles. Now, there is a force, there's a strong force of attraction that holds these particles together. That force is called electrostatic force of attraction. Electrostatic force of attraction, that is arrangement. In terms of movement, how do they move? Particles in solid, they do not move, but they vibrate in their fixed position. They vibrate in their fixed position. They don't move because they are closely packed due to strong electrostatic force of attraction. Liquid, in terms of volume, it has fixed volume. In terms of shape, no fixed shape. It has fixed volume but no fixed shape. It takes the shape of a container. If you put it in, do you have any container? Okay, it's okay. So let's say this one is a bottle. If we put liquid in this bottle, it will take the shape of this. So liquid has no fixed shape. It takes the shape of a container. In terms of compressibility, it is slightly compressible. In terms of particles movement, particles arrangement, they slightly further apart and are arranged in an irregular pattern. Okay, and the force that holds these particles together is there is a weak electrostatic force of attraction, slightly weaker than the solid here. In terms of movement, how do these particles move? They move by sliding over each other. That's how they move. Gas. In terms of volume, no fixed volume, no fixed shape. In terms of shape, a gas occupies the available space. So it takes the shape of a container. It is N. In terms of compressibility, that's why it's highly compressible. So we use gas to even inflate car tires and even bicycle tires, or even football tubes. Okay, we also have to look at, in terms of movement of particles, arrangement of particles rather. So particles are arranged are further apart. Okay, arrangement of particles are further apart. So there is very weak electrostatic force of attraction here, very weak, because particles are further apart. In terms of movement, they move at higher speed because there is space here. They don't even slide over each other. Okay, so these are properties of solid, liquid, and gas, or states of matter. Now, there is, last but not the least, there is what we call the change of state of matter. So you can have solid here, liquid, and gas. Solid, liquid. So the process of change of state of matter from solid to liquid is called melting. Melting. You have, for example, an ice, you have to melt it, or it has to be put at temperature that is slightly higher than the freezing point, or the melting point in short, for it to melt to liquid. Then the change of state of matter from liquid to gas is called evaporation. Evaporation there, Then there is a direct change of state of matter from solid to gas, which is called sublimation. Even this is also sublimation. The change of state of matter from gas to solid is also sublimation. Then the change of state of matter from gas to liquid is called condensation. Then the state of matter of change of state of matter from liquid to gas is freezing or solidification. This is also known as liquefaction. This is also known as freezing or solidification. And the temperature at which a solid melts or changes to liquid is called melting point. The temperature at which a liquid changes to solid is called the freezing point. Okay, now there are two terms that are associated with when it comes to energy gained and energy lost or released to the environment. Two terms. There is what we call endothermic reaction and the exothermic reaction. Endothermic reaction, this is when heat is absorbed from the environment, Then exothermic reaction, this is when heat is released to the environment. So now when you look at these, which direction do you think is endothermic reaction? Remember, as you are going from the left to the right, heat is gained. So it's endothermic reaction. An ice needs to gain heat or heat energy for it to melt to liquid. Liquid needs to gain energy for it to change to gas, to evaporate. So solid to gas is also endothermic. So as you're going this side is the endothermic reaction. Then as we are going backward from the right to left is the exothermic reaction. Okay. All right, I think that's all. In the next video, we're going to look at heating and cooling curve and examples of substances that undergo sublimation, this direct change from solid to gas and gas to solid. Thank you very much. Remember to subscribe and subscribe to the channel and also like the video. Thank you.